Good morning everyone. So in the last time we have seen the derivation of gravitational acceleration, and also before it we have seen some of the equations related to the free falling object and the object moving in upward direction, right? So today we are just apply all the equations in a sums, right? Which are the equations? So generally the equations are, first of all, G is equal to capital G capital M by R square. It is the equation for the gravitational acceleration. Generally, you know that the gravitational acceleration depends on this constant, gravitational constant, right? At here, the mass of Earth, and at here the radius of Earth. And as you know that the mass of an Earth and the radius of an Earth never be changed, right? This radius and the mass will not change. Here it is also constant, so all the values are constant. So according to it, you can say that the value of G is also the same, means it is a constant, which is taken as a 9.8 meter per second square. So generally, the gravitational acceleration, the value of that is a 9.8 meter per second square. Of course, there is a little bit change in it due to generally the hilly areas or something like that. As you know that at the hilly areas that R will be more, and not only that, our Earth is also not a exact sphere, right? There is a small radius at a polar one, right? And at the equator, there the radius is higher. So according to it, also we can say that at polar, the value of gravitational acceleration is higher, and at equator, the value of gravitational acceleration is less. But as been taken as a G 9.8 meter per second square at every place of it, because the value which is just changes is not a much like a 9.8 does not becomes a 9.2 or a 9.3. It just changes like that, the 9.78 a 9.82 or something like that. So as a mediator, we are taking a value of gravitational acceleration as a 9.8. It is not that much changed at here, right? So we are taking the gravitational acceleration as a 9.8, and sometimes in our sums we are taking a value of G as a 10 meter per second square for making the calculation easier, right? But for that, this value will be given to you in your example. If the value is not given to you, then you have to take this value, G as a 9.8 meter per second square, and only you can use this value when the object is free falling or object is moving in an upward direction, right? Now, so it means you have to use all the equation in a one sum, right? Okay, now for free falling object, what are the equation? It's a V is equal to GT, right? The H is equal to 1/2 GT square, right? And the 2GH is equal to V square. It is for free falling. And for the upward, the U is equal to G. H is equal to UT minus 1/2 GT square. And the 2GH is equal to U square. Right? So here it is the equations of free falling object and the object which is moving in an upward direction. But as you know that these equations are too much. It's like a 6 equation, and here it is a 7. How can we remember it? Then if you can't remember, or if you do not want to remember this equation, then at least you have to remember the equation of constant acceleration, which we have seen in chapter number 8. And as you know that for chapter number 8 and chapter number 9, we have to remember that equation. Then why not we are using that equation in this chapter also, which is V is equal to U plus AT. S is equal to UT plus 1/2 AT square. And the 2AS is equal to V square minus U square. So we are using this equation instead of it. And according to the free falling and the object moving in upward direction, we are just taking the value of it. As you know that these equations are also come from it by putting the value of U, G, H or something like that, right? So at here, you do not need to remember these two equations. You just need to remember this equation. As you know that these equations are used in chapter number 8 and 9 also. So you have to remember it for that one. So why not we are using it in this chapter also. So you have to remember these three equations and the value of g, which is 9.8 meter per second square, which is near value of the gravitational acceleration. It is not actual, because at every place this gravitational acceleration is a little bit changes, right? So as a mediator we are just taking the value of g as a 9.8 meter per second square, and if the value is given to you as a 10, then we have to take g as a 10 meter per second square. So now we are applying all the equation in some of the sums, right, related to the object which is free falling due to the gravitational force or going in upward direction, right, in the opposite to the gravitational force, right? So now we are going to see the sum of the equation, the sums related to it, and we are going to calculate the questions, right? What are the questions? The first question is, in your book, just open page number 136. Page number 136, there is one example 10 point. Okay. What is the question? There is one toy car which is falling from some height and touches to the ground at 0.5 seconds. Means there is one toy car and it just falling without any force. We are not playing it. It just fall by itself. Right? So at here we are not using our force, and it's falling due to the gravitational force of Earth. So it's falling and touches to the ground at 0.5 seconds. So at here the time is given to you, which is 0.5 seconds. Right? Now, for making the calculation is even, we are taking a value of g as a 10 meter per second square. So the value of g is 10 meter per second square. And as the object is falling from some height without any external unbalanced force, it is known as free falling. And as it is free falling, its initial velocity is 0. So u as a 0 meter per second square. Now what you have to calculate? In the first one, calculate the velocity of a car when it touches to the ground. Means when it's just falling, there is a one thing is happen, the falling of the car. Before falling, its initial velocity, and after falling, its velocity becomes the final. So when it touches to the ground, it gives you the final velocity. And as you know that the u is, you have a u, then you have to find out the v. So at here, you have to find out the v. So how can you find out? By using this equation. V is equal to u plus a. But as you know that here it is, the object is free falling. So instead of E, there is a gravitational acceleration which is g. Instead of acceleration, we are always taking here a gravitational acceleration. Right? Now, the value of u is 0 plus g is 10 and the t is 0.5. So 0 plus 10 into 0.5 by 10, if I am just removing a point, then it gives you a 5 by 10. These 10 are cancelled out. So at here, 0 plus 5. So it gives you a 5 meter per second. So V is a 5 meter per second. It's your final velocity. Now what is the second question? That you have to find out at 0.5 second what is its average velocity. Now you have to find out average velocity, which is VAV, or average speed, right? VAV. Now, as you know that for finding average speed, we are using a total distance by total time. But as we do not have the distance, we can easily find out by VAV by putting or taking the arithmetic mean of U and V. If you take the arithmetic average of U and V, then you can also find out the VAV. As at here, the object is moving with the constant acceleration. If object is moving with constant acceleration, or you can say that at the same time the change in a velocity means the acceleration is same, then you can easily find out VAV by taking the arithmetic mean of final and the initial velocity. Means there is a two velocity u and v, the initial plus final velocity divided by 2, because there is a two terms, right, u and v. So at here 0 plus 5 divided by 2. 0 plus 5 is 5 by 2. So it gives you 2.5 meter per second. So it's a VAV. So it is a VAV. Now here is a 2. Now third one. What is the third one? What is the distance which is covered by top height, which gives you a height at which height it just found, right? So h is equal to ut plus 1/2 gt squared. Instead of s we are taking h, right? So at here, so the h is equal to u is 0, t is 0.5 plus 1/2, g is 10 and the t is 0.5 squared. So at here it becomes 0 plus 1/2 into 10, and 0.5 square means 0.5 into 0.5. As I said, if you want to take a square, then you have to just put it for a 2 times, right? So it's a 1/2 into 10, 0.5 by 10, 5 by 10. If we just remove the 0.10, this are cancelled out. So what's your answer? 5 5 is 25 divided by 10 to the 20. So h is equal to 5 by 4. Right? 5 5 is 25, 4 5 is 10. So it's a 5 by 4. And as you do the sum of 8 or divide it, then 4 1s are 4, 1 0, 4 2s are 8, 2 0, 4 5s are 20. So it's a h is equal to 1.25 meter. So here it is the height. Okay, now if you do not want to find out the average velocity by this equation, then you can use this equation also. A VAV is equal to total distance by total time, which generally we use this equation, right? So what is the total distance? The total distance is the total height which is covered by the car when it's free falling. It just covered this height, so it's a total distance covered by it. So it's a 1.25, and the total distance is total time is 0.5. It reaches to the ground at 0.5. Now remove the point, then 125 divided by 100, net 5, 10. 25 5 is 125, and 25 4 is 100. So it gives you 10 by 4, which is 5 by 2. 2 2s are 4, 5 2s are 10. So 5 by 2. Add here 5 by 2, which gives you a 2.5 meter per second. So if you want to just find a VAV by finding this h, then you can also find it. Otherwise, you can do this one also, because it is the arithmetic mean of initial and the final velocity. And you can only use this equation for finding average velocity when the object is constant accelerated. Otherwise, you can't. Otherwise, you have to use this equation only. You can use this equation only when the object is moving with the constant acceleration. Just see it. Now we are going to see another question, which is 10.3. Example 10.3. What is the question? One object is falling in the upward direction at a 10 meter height. So we are just falling object in upward direction and it reaches to the 10 meter. Right? Now, what do you have to find out? So first of all, what is the velocity by which we just throw it. Means at here what the thing is happened that the object is throwing. Before throwing it is the initial and the final after throwing, right? So the initial velocity that you have to find. At which velocity that you are throwing it, right? And the second one, what the time it takes to reach the maximum height. So at here, what is given to you? That you have a maximum height which is h. The h is given to you which is the 10 meter. So this object is reaches at a 10 meter which is the maximum height attained by it. When we throw it, it just attains a 10 meter. And as you know that object is moving in a upward direction. Its final velocity is 0. As I have said in the video of the object moving in upward direction, right? Always you have to remember that at height the velocity is 0. When object is free falling, it's initially it is on a height, so initial velocity is 0. And when object is throwing in upward direction, finally it reaches to the maximum height, so the final velocity is 0. Always on height the velocity is 0. So the at here the x is given to you and v is given to you. In this example, object is moving in an upward direction and there is a gravitational force is also applied on it, right? So its velocity decreases and once it becomes 0. So at here also it decreases at a rate of a gravitational acceleration. So at here we have to take the gravitational acceleration. But the value is not given to you, so you have to take it as a 9.8 meter per second. Understand? So you have to take the 9.8 meter per second square. Not only that, you also have to remember this, the object is moving in upward direction. So we have to take the g as a negative. Understand? So we have to use a g as a negative. Understand? Now, the first of all, what you have to find? You have to find out the u. What is u? Right? For that, we are using the equation. We can't use this equation. V is equal to u plus g. We have u and g and v. You have to find out u, but there is no t, so you can't use it. Not only that, you can't use this equation also because there is also a t is included in, right? So for finding, and as you know that if you want to find anything, then there should be only one unknown. If there is more than one, then you can't use that equation. So we are using this equation. 2gh is equal to v square minus u square. At where there is no t. We know the g, the value of g is there, the value of h is also there, value of v is also there. So we just don't know the value of u, which is only one unknown, so you can easily find out. Now the 2. G is 9.8, a minus 9.8. Sorry, it's a minus 9.8. And the value of h is 10. Now v square, it's 0 square minus u square. Right? So at here it becomes minus 2 into 98 by 10. We have just multiplied it. So the whole term becomes minus. So minus 2 into 98 by 10 into 10 is equal to 0 square 0 minus u square. This 10 are cancelled out. Right? So what is the value of 98 to 7? 8 to 7, 16. 1. 9 to 18 and 19. It's a 196 is equal to minus u square. These two, both the minus are cancelled out. So you get 196 is equal to u square. So you can say that it is a u square is equal to 196. So if you find out u, then you have to take square root of 196. What is the value of square root of 196? It's a 40. Right? It's a 40. So u is a 40 meter per second. So the object is just throwing with the velocity 40 meter per second in upward direction. Understand? Now what you have to find out? Now in the second one, you have to find out the time t. What is the time it takes to reach a maximum height? So you have to find out the t. And you can use, at here we are using this equation. Now you can use any equations of them 2. The v is equal to u plus at or h is equal to ut plus 1 half gt square. So we are using a easy one. V is equal to u plus gt. At where we are taking a value of g as a minus, right? So v is 0. U that we get, it's a 40 plus it's a minus 9.8 and at here t, right? So at here it's a 0 is equal to 40 plus or minus minus 9.8 t. Now put this 40 in the another side, then it gives you 0 minus 40 is equal to minus 9.8 t. 0 minus 14 gives you minus 14, so it's a minus 9.8 t. Now you have to find out t, so minus 9.8 should be taken as another side, and it is in multiplication, so it becomes in a division. So this minus first of all cancel out. Then 14 into 10 divided by 98 is equal to t. Understand? So at here we are just removing this point, which is a 9.8, which gives you a 98 divided by 98, so it gives you a 10, right? Now fourteen sevens are 8. Right? So it gives you a 10 by 7 is equal to t. Right? So if you take the 10 by 4, 10 by 7, then it gives you a t is equal to 10 by 7. So 7 ones are 7, 3, 7, 4 is 28, right? 2, 20. 7 2s are 14, 60, 7 8s are 56, right? So it gives you a value like that. So we can say that the t, I'm just taking a 2 digit from the point, so 40 t. Second, as after 2 there is a 8 which is more than 5, so I'm just adding a 1 in the 2, so it gives you 1.43. So here it is your answer. Like that you can easily calculate the u and t, right? So now just see. So here it is some of the questions related to the equations of free falling object and the object moving in upward direction. Now there is some homework that you have to do. From the exercise, the question number 13, 14, 15, right? And okay, now only this one. Okay, so you have to write down the question number 13, 14 and 15. Here is your homework, right? Thank you.